Right, we're looking at inequalities 4, and for this one we're looking at what they call, if I'm looking at it now, they call it compound inequalities. Compound inequalities. So it's a bit more confusing. Compound inequalities. Let me write that out. Compound inequalities. So let's look at an example to see how it works. Okay, here. So this looks confusing, doesn't it? We've got a value in here and we say this value is greater than 7, but also this value is less than or equal to 15. So we're going to have a value here that is going to make such that when I add 3 to it, it's greater than 7, but also it's less than or equal to 15. So what I'm going to do is detach. Same idea, same idea. What's attaching itself to x? How is it attaching? What's the opposite? So I take away 3 here from everything, so it becomes 4, and we end up like that. Essentially, I've just taken 3 from each side, so it's all balanced. Otherwise, it wouldn't be balanced, would it? So you take 3 from everything, and then it's kept in balance. Everything is true. Now, how do I demonstrate that on a number line? This is interesting. Here, there are 2 key numbers, aren't there? There's my 4 and my 15. Okay, and I could have all the other numbers here as well. 5, 6, 14, ... 16, 3, ... So they can all be like that. So if I was doing an exam, I'd write it all out, proper scale, etc. But for now, I'll just show you how this works. Put a 0 above the 4, put a 0 above the 15, and then it's between these. It's less than or equal to here, but it's greater than or equal to there. But don't forget, it can also equal 15. So there you go. That's how you define that. And that's kind of an important thing to understand. That's how you do compound inequalities. So I'm going to do one more question on this, and then I'm going to go inverse it and see what you can do with that. There we go. So again, you can see what's attaching here, and you want to get rid of it. So again, I keep doing the same thing, because if I do the same thing all the time, in an exam situation when I'm stressed and I can't remember anything, if I've got a courtyard of habit, my comfort zone, then I can get back into that and I feel better about it. So having that same regularity, that routine, is really kind of important for maths here. So what do I want to get rid of? Anything attaching itself to x. Let's make this a bit more challenging. Let's make that 2, shall we? Let's make that 2 and then see what happens. So I've got 2 things now attaching themselves here, and I've got to detach those away. So first thing I'm going to do is the weaker link is taking away. So I'm going to do the opposite of taking away, is adding 16 to both sides. So I'm going to add 16 to both sides, so that makes that 37. Add 16 to make that 60. Now I've got the times by 2, so I want to do the opposite of that. So I want to divide both sides by 2. That looks a bit messy. 36 is 18, so 37 is 18 and a half. And a half of 60 is 30. Now if I were to draw this on a number line, you can see how I do it, but of the half makes it awkward. So again, understanding the question, and if they said what's the integer value, what's the integer, the whole number, then it's got to be greater than or equal to 18.5, so it'll be 19, wouldn't it? Because 0.5 isn't an integer. Okay, but on the number line, if you had to illustrate it, you'd illustrate it at the 18.5 mark, just like you normally would do.